Hi. It's time for, apparently, episode 14. So last time, as it says in the description, I tried to do my best to wrap up text mode stuff, trying to get the NES to have basic character printing facilities so that we can jam Microsoft Basic into it. And that's going pretty well. We are very close. I have mocked up a character. Mocked up isn't the right word. I have assigned a character to everything in the printable ASCII set. They may not all be beautiful because they are yanked from the Super Mario Bros. 3 character ROM, but they all exist. And on top of that, we implemented some basic control characters. We've just implemented... I don't think we've even implemented space, so we'll have to do that really quick. No, we did. We did, because we have that assigned to a... I'll have to double check that. I think I assigned that to a blank character. Subsequently, yes, basic control characters. Wereworm, good evening. We got line feed and carriage return doing their thing. And now, you know, when we hit the bottom of the screen after doing a whole bunch of line feeds, we're gonna need to, like, deal with that. And software scrolling, which is basically where you take everything on the screen and copy one row up, and then copy the next row up, and then copy the next row up until you're done, is going to be crazy slow on this thing. So we don't want to do that, and the NES PPU supports scrolling offsets, which is how you have side-scrollers. We've figured out enough that, thankfully, if you're just joining us, we are using, well, this folds in some semi-bad news. We are using this, which if you've been following along, you might be able to tell that it is slightly broken. But that is a Super Mario Bros. 3 cartridge, because that's what I'm basing things off of. I've basically made it into kind of a repro cartridge, sorta, kinda, in order to get my own code on there. Anyway, with Super Nintendo cartridges, you can either mirror, you get 4 screens worth of map. But you can, with the memory that's available in the NES, you can only have 2. And then they either get mirrored this way, or they get mirrored this way. So we figured out, too, to use the mapper chip that is on the Super Mario Bros. 3 cartridge. We can, in fact, switch our mirroring to being like this, which is good because when we scroll this way, this wraps because of the mirroring. So the bottom line here, well... So if the screen is here, the visible screen, and we scroll, you know, one line up, that line is going to reappear as the top of the mirrored segment at the bottom here. So all we need to do for software scrolling is when we move up a line, we want to clear out everything in the topmost line and shift the whole thing up one position, until we've gotten all the way up to the top of the screen, in which case we've wrapped and we can just set it back to 0 without anybody noticing. Or at least that is the theory. So that's what I'm going to implement today. But yeah, so gotta fix this camera slightly, maybe. Sorry. That'll do. Yeah, so what happened here? So if you were watching the last one, you will know that the NES did not appear to be working at the end of the stream. And thankfully, that just turns out to be because at some point the wire on the power brick went wonky. So it's flaky, but it works. So that's fine. The NES is okay. But yeah, moments ago, I accidentally yanked the NES off of the table it was sitting on. And it did not hit the ground. It was held up by its video cable. So it's still good. But this cartridge that we were working on flew off onto the floor. And I subsequently, this half of the Tower of Power fell off during the impact. And I then subsequently stepped on it so hard that it stuck in my foot. So I need to fix up these bent-ass pins, which shouldn't be too bad. And then I need to solder one of my redirection wires, one of my bodge wires, back onto this thing, which the soldering iron is already heated up, so this should go fast. And then it should be fine. It should be just fine. I don't see any reason for it to not work. And we just got to stay positive, everyone. Yeah, this seems reasonable, except that I believe it was... Yeah, I can tell it's this pin because it's all melty around it. And that is a sign that there has been some heat. And then I just have to make sure I have this the right way around. And pop it back in the socket. And yay, it plugs right back in. Everything's going to be fine, you guys. But I do have to try and trim. Here, let's use some hair scissors, some hair cutting shears to try and do this. Got to trim this, or what's the word for this? When you take the shielding off of a wire. Very straightforward term. That is completely escaping me. We got to do that. Anyway, it's already done. So I hope that was thrilling. And my solder is right here. There we go, fixed. Moving on. Thrilling. You gotta move that back to where I can flip the whole thing off the table and drop it again and break it again. To enhance the drama. Okay, I think that's all we get of the workbench today. It's time to move back to the boring world of software, where anything is possible. And my computer apparently killed itself at some point last night. So let's pull everything back up. Okay. So also, the idea was when we have a line feed. So I was just gonna start with implementing checking to see if we need to scroll in the line feed code. Because I can move it out and commonize it so that it can also be run in the case of just going to the new line because of wrapping. And so we're just gonna start it with the line feed and then commonize it. And so what was I doing? Right. So the first thing that I was thinking is, let's just... I'm just going to start writing my code here, and first thing to check is, actually, let me go up here and make a variable. We'll reserve some area in the 0 page for a variable called, I don't know, is scrolling. Because when you start this thing up, the cursor starts in the upper left, and we don't start scrolling until we hit the bottom of the screen, at which point we're always scrolling. Every time we do a new line, it's going to require a scroll. So we're just going to keep checking to see if we've hit the bottom of the screen, and then once we have hit the bottom of the screen, set this is scrolling flag on, and then we also check before we even do the see if we're at the bottom of the screen check, we check to see if the is scrolling flag is set, and if it's set, then we just scroll, because there's no need to check. So that will be at 05 on the 0 page. And subsequently, we need to check to see if we're at the bottom. So I'm kind of falling asleep. So sorry if my energy is a little bit low today. I am so missing it. Check line feed. It's right there. Okay, so right here, let us start by loading the thing that I just made. The is scrolling variable. And branch if... I guess branch if it is set. Oh, we should probably clear that to 0 when our program starts up. You need to initialize things, you see. There's the best place to do that. Right ahead of echo loop. Yes. Because that's our kind of halt loop. No. Right before this test code. Yes. Sure. Yeah, right here where we're setting scroll to 0, 0. That seems fine. Yeah, we're doing a bunch of initialization here, so why not? Yeah. When we first start, we do not yet need to scroll. So, load a 0, 0. And store a into that thing that is scrolling variable. Okie doke. Now, back to where we were. Check line feed. So, if it is set, which would be branch if not 0, which I have to keep saying this because if you're not familiar with 6502 assembly, branch if not equal is the same thing as branch if not 0, and vice versa with branch if equal. So, branch if not equal, I'll make a label, a temp label called do screen scroll, and we'll just put that down here. But, assuming that it was not set, we need to get the... Okay, so double checking the line feed code, actually. So, we checked to see if it was a 0A, which is the line feed character. If it was not 0A, we jump to print character N, which is the wrap up and exit the print character routine, because there's nothing to be done. Otherwise, we get the low byte of the screen address, increment it by a whole screen width to make it jump down to the next line, and then we store it, and then we do a little math because the screen address can be up to 16 bits long. So, some of the magic is because the screen is 32 bytes, and that is a power of 2, that is very convenient, or 32 bytes, not 32 bytes, it's 32 character locations. So 32 addresses. Anyway, it's exactly a power of 2. So the nice thing is that means that it's just literally the last 5 bits of the screen address that we're writing to is the X position, and the Y position is the whole rest of it. But even though this is increasing the Y by 1, we still need to check to see if it wrapped, which is what this is. And if it wrapped, we also need to increase the high order byte of the address. Anyway, just a recap on what we're doing here and why we're doing it. So, if it didn't wrap, which is what this and E0 is checking, then we go to print character N, there's nothing more to do. Otherwise, we do need to wrap. And actually, and so we just increase the high order address by 1. But actually, it now occurs to me, doing the actual screen scrolling is probably going to want to happen like immediately after, well, no, it doesn't have to happen immediately after we increase the address. We just have to be careful because we don't actually want to go to print character end if we don't want to wrap this value. We need to make a new label just to skip incrementing the high byte. So let's make another one called, check scroll needed. Let's do that. And that will just allow us to jump over that increment if we don't need it. So we load the is scrolling because this is a line feed, so we know that we incremented 1 line. So if is scrolling was true, then we just go straight to do screen scroll, which we have yet to write. Otherwise, this is the part where we figure out if we are at the bottom of the screen yet. And the bottom of the screen is going to be This I should know. It was actually... We can look this up because... So that echo loop that I was talking about before, I had some test code in here. This is like just the halt code that after we do all the setup and print an example string on the screen, it just hangs out in this loop forever. And in here last time, I was playing with scrolling, and I was just scrolling the whole screen and then apparently stopping. I don't know why it's stopping. That actually wasn't supposed to happen, but it is. So, I believe... Let's see. So in the echo loop, we were waiting for a vertical blank is what this is. It's checking a register to see if we're in vertical blank. Then if we are setting the scroll value by writing the values in the X and the Y register to the scroll register on the Nintendo's PPU. And subsequently increasing the Y register, which is holding the Y value conveniently. And then we increment it by 1. We slap it in the A register, or we increment it, slap it in the A register, and then see if it was F0. The reason I'm going through this is because I was doing this check to see if we had wrapped and gotten to the bottom of the screen, which I believe is 30 lines long. It's 30 characters. Yeah, that would make sense. So it's 30 tiles. I was just double checking because I think it's like EF. That makes sense because F0 would be the next thing after EF where it would wrap. So I think that makes sense. But we can double check with a calculator. Always check your work. Switch this to programmer mode. And like I said, I'm pretty confident it's 30. Each screen is 30 tiles tall. And each tile is 8 pixels tall. Right, so it is 240 pixels tall. And 240 in hex is, look at that, F0. So what we need to do is basically, I guess, check if, because this gets weird because it's the, well, it'd just be F0 left shifted by 5, right? Because we have to offset it by that X address. And also there is a 2 at the beginning of everything because this map begins at the address 2000 in PPU memory. So, putting that all together, I believe if we just take F0 and left shift it by 5, that is saying that is at 1E00, which would then be, you add 2000 to it, so that should be 3E00 would be the actual address. So it looks like we just check the high memory address, or the high byte of the memory address, and see if after incrementing it is 3E. If it is 3E, we need to scroll by a line and turn that is scroll flag on, I think. As always, I am the king of off by 1 errors, so we shall see. But let's go by that logic. Let me just actually do another sanity check and make sure that if we look at the PPU documentation, that the end of PPU, or the end of the map's address space is roughly there. So name table 0, which is the one that we're writing to, is from, yeah, something's way off. I really effed up my math there. It is from 2000 to 23FF. So yes, I have made a definite pigs here. But why? Probably because, for starters, we were working in pixels, not characters. I have to go back to characters because this is not... it's weird because the scroll isn't. I mean, it's not that weird. It makes complete sense. But the scroll is going to be in pixels, but we're working in increments of characters. Each byte in the name table, which is the thing that holds the tiles, is one character, and there's only 30 characters tall on the screen. So still shift by 5, I believe. I mean, I guess, it would be if we are at... Yeah, I mean, I'm overthinking this so much, as is my style. The end of name table 0 is actually not... the end of the name table proper is not actually at 23FF, because there is the... let's see if it's described on this page, but it's the attribute memory, which determines what palettes get assigned to each cell on the screen. I'm probably re-explaining a bunch of stuff way too much, but I'm trying to think it through for myself here. Anyway, let's look up name tables. Let's see where the name table ends. They are each 3C0 bytes. So, I mean, I guess theoretically, one would think if they're 3C0 bytes, then the last character in the name table would be at 3BF, one would assume. So I think literally if we just check to see if the address is 23C0, it's not quite that easy, because we're really gonna have to check both of the bytes. Probably, because there's some Y in the low byte too, so we're gonna have to maybe let's just check the high byte first, and if the high byte is 23, if it's not 23, then we don't have to check anything else. So yes, if the high byte is back to our code. Check line feed. Okay, so the first check is can we can't really guarantee what's in a, can we? So we only use the X address in the increment the high byte code. So actually we should, the low byte should still be in the low byte should still be in A. Not that I care very much about the low byte right now. Sorry, I was just thinking through something, because hello to Brazil. Very cool to have people from all over the world tuning in. Join me on this journey, won't you, of trying to figure out how to scroll a Nintendo screen, which is very simple, but is hard for small-brained men like myself. Sorry, so what I was just thinking about was it doesn't really matter. I was just thinking about the fact that always when we get to the 23C0 address, that would indicate that we are, well, 23C something address, that would indicate that we are that we passed the bottom line. That would only ever happen at this step. It won't happen when we do a wrap, because it's incrementing from whatever to from 23 whatever to 23C0 in increments of hex 20. But that's a micro optimization, and that is not important right now, and I don't think it really makes a difference. So yeah. No, you know what? I think I can make that optimization. I think that could make some sense. I'm just thinking of the registers and what values will be in them. I guess really the logic is we won't ever hit this code when we wrap to that address or when we increment to that address. So we definitely can't. There will be no case that happens and our high byte of the address is in X. So we're just gonna have to reload it regardless. So let's do that. Yes. My brain is... I say this every time. I just have a sluggish brain. All right, so we need to... Let's go ahead and... I'm going to need to use A either way, so... Load A, the low screen address, which we... Or no, the high screen address. Because I need to check it against stuff, and that needs to be in the accumulator if I want to do that. So I cannot get too clever for this. Anyway, so load screen address +1 and check if it is. Compare it against 23 and branch if it is not 23 to totally bail out of here, because we know that if the high byte is not 23, then we definitely don't need to scroll. However, if it was 23, then we also want to load the low address back into A. There's got to be a better way to do this. What if we... Let's transfer A into X to back it up. Yeah. That way I don't... Because I already have that value inside the CPU, inside of the A register, so it would be wasteful to slap it back into memory and then pull it back out. So, let's stash it in X. Check for 23. Then, subsequently, when we then need to check the low byte to see if it was C0, then we will transfer X back into A and compare it against... actually, we need to AND it with... just like we did up here, because we want to get rid of the low 5 bits, because those indicate our X address, and that we might be somewhere over, not at X0. So we need to clear those bits out. So, AND it with E0 to get rid of the low 5 bits, and then finally compare it against C0, and branch if not equal to print character end. There we go. There's, I'm sure, some way in which this isn't quite right, but whatever. You got to start somewhere. So, if this all checked out and we are at 23C0, then we need to do screen scroll. And what do we do when we want to scroll the screen? There's the real question. I think the first thing we want to check is if our screen address has exceeded the end of the screen, as it would have just done the first time we scroll, we want to wrap that address so that it goes from the bottom to the top, basically. Right? Yes. Because we're going to scroll the whole screen up one location, and now the first line will go off the top of the screen and become the bottom line. So we want to do that, which means clearing our Y value, really. So if we want to check for that every time we scroll, which makes me wonder, do we really just want to use this code? Because we're already, that case is the case for when the value is the value ANDed with E0 is 23C0. Basically, when the Y is 23C. And we really want to check that every single time to see if we need to wrap our address. Right? Right. I think so. So... yeah, damn. Actually, I think because of that, this idea of having this is scrolling flag is actually going to end up being redundant, because we're going to need to do that sort of check regardless, just to see if we need to wrap the address. And so it's not any faster to have a flag, because we'll need to execute this kind of code anyway. So never mind that idea. Which I guess saves us some zero page space. Get rid of this too. Okay. And I mean, I guess we can keep calling this check scroll needed, whatever. Yeah. Thinking through things some more. So, this code is more or less the same, but now takes on a slightly different meaning. So we stash our A, which is the low address, and do that whole comparison to see if the high byte is 23, and if not, go to print character end. Sorry, I'm just thinking. Because we still do need to... we don't start scrolling until we wrap this address for the first time. But after that, we don't scroll when we wrap the address. We scroll every single time. So actually, yeah, we still do need that flag. Because every other time we are going to keep scrolling. What even was this? I don't know. Load X is... well, no, because this is still going to be... oi. Yeah, we're not going to be checking this yet. We will always want to check for our wrap. Boy. Anyway, so let me think this through. So this code checks to see if we were at 23C anything. If we were, in fact, at 23C something, then we both need to basically set the is scrolling flag, because we wrapped, so whether we were scrolling or we weren't scrolling, we're scrolling now for sure. And we need to reset the Y address. So let's reset the Y address first. And this is just going to need to jump to a different place. That's really what's up here. So ignoring that for now. Actually, heck. Actually, this is going to be... basically, we need to... if... let's think this through. If it didn't wrap and we are not scrolling, then we can just bail. We're good. Because we don't need to scroll, we don't need to do anything. So... basically, if it did wrap... oi. This is painful to watch as it is to process. Derek says, looks like I found the stream going live again. Missed a few days of progress, but the project seems to be moving along. Yeah, if you miss an episode here or there, you're not going to miss a ton. Project moves slow. It's fits and starts, you know? Lord. All right. If it wraps, then we need to check if we need to do... No, if it wrapped, we definitely need to do a scroll. If it didn't wrap, which is this case... So if it didn't wrap, then we also still need to check if we have to scroll. So if it did not wrap, let's do this. Yeah, I think it would make more sense to do a branch if equal. So in the case that it did match 23C something, then we will go ahead and branch to test scroll. Let's call it maybe. Wait, no. Just do screen scroll. Frick. And then we will skip this code, which is going to, in the case... Okay, yes, so we can now check... Ors are weird for me in assembly, because that's basically what we're doing. We're checking two different cases, and either of them can be true to make a scroll, which is either that we wrapped or we were already scrolling. So, now let us load a is scrolling, because in this case, yeah, here we were definitely needing to scroll, so we'll just jump straight to the part that does scrolling. Otherwise, if we didn't wrap, yeah, this is finally coming together. If we didn't wrap, then we need to check if we are scrolling, and if we are not scrolling, then we can just jump to print character end, because there is nothing to be done. We didn't wrap our address, so we don't need to reset our address, and we also weren't scrolling, so we don't need to do a screen scroll. There. I think I have figured it out. So, if... okay, so if it was equal... Actually, let's make one more label, because the thing is, I also need to do the part where I clear the address, which only happens in the case that it was equal, but scroll happens either way, so we kind of need a pre-step. So do maybe wrap y address, and we will put that here. And when we wrap y address, what we need to do is, let's see, we already have, so we currently have the low address in A when we get down here. So what we get to do easily is, and we already, actually, we're gonna have to reload it because it is getting munged up by this. I could just do TXA again, because it's still in X. We haven't screwed with X. So let's do that again. So transfer X into A to get a clean copy of that low byte. Then and it, but the mask will be backwards, because we want to clear everything but the last 5 bytes. Sorry. What is that going to be? 1F. Herp. So we and it with 1F to clear out everything but the X value of the address. And then store that back into the screen address variable. And then we can just load a 0 and store that in the high screen address. And then finally we get to the do screen scroll part. And at do screen scroll, the two things we need to do are clear what is the topmost row right now. That's the part that's going to melt my brain a little bit. The easy part is doing the scroll, because we just need to take whatever the scroll value is and increase it by 8. And then wrap, because we're going to have to do another wrap if we have scrolled all the way around to the bottom of the second half and the second mirroring of the screen. So which one of those is least painful? Let me start by thinking about which is the line that we need to clear. So in the case that we've done our first scroll, the line that we need to clear is the first line of the map, because that's the thing that will have just scrolled off the top of the screen. And then it's going to be each subsequent line. I'm just trying to think, there's got to be, surely I don't have to keep track of a separate, value to keep track of what line we're clearing, because it's just going to be always relative to where the cursor is, right? And it's going to be the line right after the cursor, really. Because the cursor will always be at the bottom of the scrolled screen, and therefore the next line is we just scrolled up, right? We just scrolled up. Our cursor just went down one line. And because of that address wrap, that's what's weird here. Yes, because it's going to be the line that the cursor lands on. Duh. That's the one we need to clear. Obviously. Oh my goodness. I am having such a no-duh night tonight. Whatever line the cursor lands on is the cursor just landed on as we moved the cursor down is going to be the one that we need to clear. Duh. So, the only funkiness about that is that we need to clear everything on that line from the beginning of that line, regardless of where the cursor is located at X-wise. So, that shouldn't be too bad, right? Because what we need to do, we need to go through the PPU to write addresses. So we can write the high screen address. Yeah, it's going to be kind of funky, because we'll write the high screen address, and then we'll write the low screen address, but the low screen address needs to be ANDed with E0, because we need to drop the X component. And then we just need to do that 32 times. And that's how we do the clear. That is that. So, are there assumptions we can make because we got to the screen scroll part? What leads to screen scrolling? What is in our registers? And Can I stash this? That's probably a good idea, so I don't have to recalculate it a couple times. I don't think we're using Y for anything. So what about at this step? After I do that and we transfer A into Y for safekeeping later. And it will just get thrown away later if it's not necessary. But if we get through all the way here, then that value should still be in Y, which is good for us. However, we don't necessarily know about the high byte of the address when we get here, because we may have screwed with A here. Is there some way we can stash it over here? Because I'm using X at this point to hang on to the what is an A? The A is the non-anded low, or the what's in X is the non-cleared low byte. So X is necessary when I get to this step, so I can't use it. So whatever, I'll just have to reload that. But I can save myself a little time and stash the pre-cleared low byte into. Ooh, but not necessarily, right? Because this is actually potentially we do wrap Y address where we have cleared the Y component of the low byte. So actually that is not an assumption we can make. Okay, F it. Let's just not try and be too clever. This is going to be my motto tonight. Don't be too clever. So let us just load the high screen address into A, and subsequently store it in, what is it, 2005? These PPU register values will not stick in my head. Nope, that's scroll. Oh, that would be why that's in my head. The address register is 2006. And you do write low then high, I believe. I mean, high then low. Yeah. So, high. Then load A. Yeah, so we have to load A, the low screen address, then and it with E0 to clear out the X part, and then store it in 2005. And now, the nice thing that we get to do is, let's load X hex 20, and we can, let's see, line, let's call it line clear top, and the PPU will auto increment as long as you keep writing data to the data register after you've set an address. So I should be able to just keep writing, not necessarily zeros. We want to write whatever. Let me check what's in the space value of our character lookup table, because that's really what I would want to write. 7D. So we'll write 7Ds 32 times. And that will clear out the line, theoretically. Uh, 7D? Is that what I just said? Woo! Oh, and we can actually load A beforehand and just keep it in A. 7D. And then here we can just keep storing. Again, there's also like a DMA way to do this in the NES, but keep it. Don't be clever. Don't be clever. So store A into 2007 is the data latch. Yep. And then let's decrease X and branch if it is 0, or branch if it's not 0, to line clear top. And that should clear our line. And finally, we just need to set the scroll value, which actually we're going to need to keep freaking another variable for our screen our scroll offset. So here we go. 06 is scroll value. And let us also, I guess, initialize that here. Load A00. We don't need to do that. Start in 2005. We'll start in 2005 again. This is initializing the scroll at the very top of the program. And then also store it to scroll value, which will start at 0. And finally, here we are. Let's load a... or actually, really, all we need to do is update that screen scroll value, and we get to print character end. We always update the scroll register because it gets futzed up by writes to the PPU of all sorts. So this happens every time. So we'll just always want to reset it using the proper Y scroll value. So let us load scroll value here. And we just need to update scroll value here. So load a scroll value, and then we need to basically, well, actually let's load it into X because we need to increase it and then check to see if it is greater than the maximum scroll that is allowed, and if it is, reset it, which should just be, I mean, that was the thing I was checking before that we already had in the echo loop, is if it is F0, that is when we need to reset it. So let us do that. I guess we need to put it in A. I guess we need to put it in A. Transfer X back into A, then compare it against literal 0 or F0, and if it doesn't equal that, then I mean, we need to stash this either way. But do we do 2 writes? Did we just do 2 writes? Or should we do 1 write? And do it the good, clean way. Okay, so if it doesn't need a wrap, then I mean, we just need a new label, basically. If it does need a wrap, yeah. If it does need a wrap, we'll jump to wrap scroll. And if it didn't need a wrap, then we still need to write the value back. So store what is currently in A to scroll value. And finally, on wrap scroll, we know we need to clear our scroll value. So let's just load a literal 00, and then store that in scroll value, and then continue on. And I think that's it, except for the fact that we need to like transplant this code over into its own subroutine or something so that it can also be used for regular line wrapping. But I think that's a first pass. I think we've got all of the major steps needed. We check to see if we're needing to wrap the address, the address that the cursor is at, on Y. And if we do need to wrap on Y, then we do it. Otherwise, we check to see if we need to scroll. And if we do need to scroll, we go here. Or if we wrapped, we also need to scroll. Ooh, that's a thing that I didn't set, is if we wrap the Y address, we also need to load a literal just a 1, yeah. Load a 1 and store it into the is scrolling variable, so that when we come back around, we know we're scrolling for sure now. That was an oversight. Okay, so we checked to see if we needed to increment to wrap the Y address. If we didn't, if we do need to wrap the Y address, we do the wrap Y address code. Otherwise, we check to see if we're scrolling. If we're not scrolling, then we're done. If we needed to wrap the Y address, we wrap the Y address and note that we are scrolling now and continue to do the scroll. If we didn't need to wrap the Y address but we were scrolling, we end up here anyway. Then we we get the high screen address, store that in the PPU address register, get the low screen address, store that, make sure we clear out the X offset of that. Yep, and then store that in the low address of the PPU. Then hex 20 times, we write 7D to the address register, which should subsequently write hex 27Ds to the PPU in order. Then finally, we load our scroll value, increment it, see if it needs to wrap. If it does need to wrap, we reset it to 0. Either way, we write it back to the scroll value variable. Then finally, when we're done printing the characters, we update the actual scroll value on the PPU, which involves loading 0 into the X offset, because we are not going to scroll horizontally at all, and then load the scroll value. Oh, why didn't you guys point this out to me? We have to increment it by 8 pixels. 8 pixels. So doing the clever increase X thing is actually not useful here. We need to let's clear carry for paranoia and add with carry a literal 08 to the scroll value. And we don't need to do that anymore. There we go. That should be better. I feel better about that. And that's it. That's our scroll code. So let's go for it. Are you nervous? I'm nervous. FCEUX. All right, it only took us an hour to get here. That's not what I meant to do. But we're ready to test our scroll code, which will probably not work first try, because that's how it goes. Oh, in fact, I should not even try, because we need to actually, like, write some code to try and exercise it. You crazy. Because right now, our kind of wait around code that I was talking about, this echo loop, is it's doing its own screen scrolling, which we don't want to do anymore. That was just for testing last time. So let us not do that. There we go. We just want our classic loop. Our classic loop forever thingy, which also means we don't need to do this. We don't need to do this. And what I do want to do, let's see. Oh, I should make a note here. Set. I should really do this earlier in the code too. This is the part that is, setting the MMC3 mapper to mirror the way that we want to mirror. So let's move that over here. Set MMC3 to, is that vertical mirroring? No, horizontal mirroring. No, vertical mirroring. Ah! Vertical mirroring. Okay, and then I am going to increase this to, I don't know, something crazy. Hex 40? Does that make sense? And 40 times, we're just going to print this here string, which literally just says here. I won't even go to it. And then we print a line feed character or carriage return. And then we loop. So if I wrote all my code right, this should do that hex 40 times, and when we hit the end of the screen, it should start scrolling. Which probably won't be super clear. So actually, in fact, before we do that, what on earth is this? What did I do? What did I screw up? Let's just pretend that wasn't there. Before the print loop, let me print the other string. Test string. Hello string. Store that in the string pointer variable in the 0 page. Load the high byte of the hello string. Store that in the string pointer +1. And JSR print string, and do that same thing. Let's do a new line character carriage return. And that way it will be a bit more clear that things scrolled. After that, it's still going to be a little bit less clear once that falls off the screen. But, you know, if anything goes insane, that's a bit of a canary. Fingers crossed. Oh God. Okay. That is unexpected. I shouldn't really be surprised, but it is not what I expected to happen. We scrolled to the right for some bizarre reason. Okay. Interesting. Well, let's just go ahead and step through this code, huh? Where should I put my breakpoint? Perhaps. Check scroll needed. Let's try seeing if we get to wrap Y address, which is gonna be somewhere. We're looking for a TXA and 1F and a store A. Oh, I closed FCEUX. What a moron. Okay, what was I looking for? TXA. What did that code look like? TXA and 1F store A. TXA. And surely it's somewhere. I'm seeing lots of TXAs and ANDs. This is it. Right? Yeah, I think so. I'm not sure how screen address could be 41 for some reason. Oh, probably because things are going insane. What's the next thing that happens after that? Load A0. Yeah, this is definitely it. So, let's put a break at E1C1. And reset this thing. Okay, so it clearly hits there quite early. Oh, okay. Why did it hit there? That's the question. Wrap Y address happens if we got to check scroll needed. We loaded the high screen address, checked to see if it was 23. If it wasn't, we exited. Then we put the X value back into A, which the X value should have been screen address plus 1. No reason for it not to be. Oh wait, there's totally a reason for it not to be. You silly man. Trying to be too clever. Because if it hopped right over this code. Oh wait, no, that's why I'm putting A and X, right? Because we know at this point, what was in A? The low screen address was in A. It's still in A. We added a value to it. We stored it. We ANDed it with E0. Oof. And then we didn't mess with it after this. So the ANDed with E0 version of the increased low byte of the screen address is in A here. So when we put it back, because I'm willing to believe that at that point, the high address and high byte of the address is 23. That's believable. But this is probably the part that's screwed up. So, firstly, why am I doing this AND again? This is already the ANDed version, right? So firstly, let's clear that. I think that's redundant. And let's see what is in A right now. Well, let me look through the code first. So we AND it again redundantly. Then we stash it in Y, which I think was actually something that I didn't need to do. So I can get rid of that too. So let's just preemptively get rid of those. But we compare the ANDed low part of the address with C0. If they were equal, then we need to wrap the Y address. Now see, this bit still, I mean, I guess we can just check what's in A right now. Because it should be, it is 0. That don't seem right. A is currently 0, 0 when we get here. Oh, you dummy dummy. You dummy man. You know what we didn't do here? Jump over the wrap Y address code if we don't need to do it. Silly man. That will really screw you up. So, let's do that. Let's clear carry because, and then branch carry clear, to... Oh, wait. Yeah, so if we are scrolling, then we need to jump to do screen scroll. Which is still weird because this should have, if we didn't get there by way of wrapped Y address, but by this check, if we did it because we fell through. Oh, no. There are a lot of other cases where we can fall through, isn't it? Yeah, we probably set is scrolling here. Though that would have screwed up the... I don't know. I'm going to rebuild it and just check, because my brain is getting fried. Okay. That's better, I think. It just kind of stopped. And then it went insane. But that's an improvement? Maybe? Let me set a breakpoint again. Just to be sure. My guess is we're hitting the bottom of the screen and it's detecting it properly, but then the code for handling the scroll is totally insane. So let us break at the do screen scroll portion of things, which is going to be load a, I believe screen address plus 1 is 01, so it'll be load a from 01, store a 2005. Well, immediate problem. It's 2006. 2006 is the address register on the PPU. We determined this. It's 2006. So I am definitely writing that address to the wrong place. So let's just give that another quick try. Probably won't fix everything, but that's definitely a fix for something. Here. Come on, blow up. There we go. Good job. Okay, that didn't improve jack, but it is writer. So now let's actually debug. Let me get the debugger out from behind my face. Oh, man. I hope I don't have to cut this short because I'm just tired. That would be très lame. Load screen address plus 1, which is 01. Load a screen address plus 1. Might be this one? Yeah, I think it's here. Load A01, then store A to the PPU address register, then load a low screen address, which is a insane value. And with E0, yep, this is our guy. So do screen scroll starts at the load a screen address 0, which is E1CE. E1CE. When executed. Reset this bad boy. And now we wait. That ain't right. But, okay. Interesting. How did we get here? How did we get to do screen scroll? What places lead to do screen scroll? If we're not scrolling, jump to print character end, clear carry, jump to do screen scroll. That's the one place that we can go do screen scroll. The other place is if we wrap the Y address and fall through to do screen scroll. I guess the one thing I can do is check the 0-page memory and see what is actually in there. Hex editor, RAM, and it's 2306. Okay. So clearly, that is not the right address for doing a scroll. It would need to be 23C something. Let me think about how we could get to do screen scroll in that case. So we get to check scroll needed, and it's really this break equal wrap Y address deal here. Did we hit wrap Y address? Did it get executed for some reason? I kind of want to check that, just in case. Because anytime that the wrap Y address code executes, firstly, it's very strange because that should be screwing up our cursor location. So I would think, I would kind of think not, but hi, buddy. Anytime that this code does get executed, the is scrolling flag gets set, which could cause us to jump to do screen scroll prematurely if that's the case. Oh, and in fact, I know where that is. That's at 5. So what's at 5? 0, 1, 2, 3, 4, 5. It's a 0. So actually that rules out that theory. Because is scrolling is 0. So that is not the case. So the only way that we can have gotten there is by following through from wrap Y address. Because if wrap Y address didn't need to be called, then we would proceed to checking is scrolling, and BNE after that, we know that's 0, so branch if not 0. Oh. That's backwards, isn't it? Because branch if not 0, it would need to be branch if 0 to print character end. There we go. Yeah. I think that makes sense. Let us clear this breakpoint. Let us open basic.nes again. Let us run, and it has crashed. Perfect. Okay, it got to the bottom. And it's still doing that insane thing, but I actually don't know if that was any better now that I'm thinking about it. So let's check to see if do screen scroll is happening at a more reasonable place now, at the very least. Hold up. Debug. Let's load that debugger back up. And let's load that hex editor back up so we can keep an eye on our values. Hey, look, scroll was required. Something's very wrong here with our video address, but let's just move on right past that right now. And let us find our breakpoint, which needs to be at do screen scroll, which again is load load A01, store 2006. Actually, let's just look for anywhere that it says PPU address. Probably this. Load Y01, store PPU address. Load X00, store PPU address. Store a PPU data. I don't understand my own code that I've written, but it doesn't matter. I just want to see when it does do screen scroll, so that is definitely right here at E169. I think. No, can't be. This is our indexing into the character map code. How about this? No, that's not it. Where on earth is it? Load A, then store A into PPU address. Here we are, I think. Yes, this is it. That is E1CE. On execute. Okay. Make sure it's running. And reset. Okay. All right. Okay, I think it did it in the right place. I think it actually did. Cool. Well, our address, our kind of cursor address is 0000. That seems right. I don't remember what the rest of these are. Let's double check. Oh, string pointer. That's 1600 apparently. Okay. Oh wait, no. Oh wait, yes. I don't know. And then 0, 1, 2, 3, 4. And 5 is 0. Which means is scrolling was set. Wow. Very good. So now I just have to step through here and see what insanity is unfolding. So we load the high byte of the address, store it into the PPU's high address thingy. That's 0, which makes sense. Then we load the low byte of the address, and it with E0, store it into the low part of the PPU address. Then we load X with 2.0. We load A with 7D. I'm just going to set a breakpoint really quick because let's just see if this clear line code worked. So I think E1E4, because that's right after our break, or our branch. Yeah, E1E4. E1E4 on execute. Okay, and run. And apparently that didn't give the emulator enough time to do anything. That's fine. A little annoying, but fine. Can I check what's in video memory? PPU memory. And let's look at to 2000s. And the first... Oh! I already have an inkling of what's screwing up. I reset it all the way to 0. I reset the cursor address all the way to 0. But it shouldn't be reset to 0. It should be reset to 2000. That is part of our issue, at least. And where does that happen? That happens... We do wrap Y address. Is it due to wrap Y address? Let's see. Oh, is this our issue? Let's see. What was in X here? Because that's going to be our... I mean, that part doesn't matter so much. Definitely this. So that was incorrect. The high screen address should become 20, not 00. But this low one might even be wrong, depending on what is in X at this point. X at this point was our ANDed with E0 screen address. Yes, yes. So we don't want that. We want the not ANDed with E0 screen address value. We have options here. One is before we do the AND, stash it in X. Or just don't worry about it. Oh, wait, no. We're doing TAX to stash it in X down here. So actually, doesn't matter. It's going to be cleared either way. So let's just reload it. Let's just reload it completely. Instead of doing TXA, because this is going to be the ANDed copy, which is why the X value will always be 0, because we already ANDed it with E0, which clears out those bits. So we don't want to do that. Let's just reload it again. Load a screen address, whatever. And let's see if I can crash FCEUX again. That would be fun. Let's clear all of these breakpoints. Delete, delete. Run. And reset. Do something good. Okay. Exact same behavior. Lovely. Well, let's just do that again. Let's set our breakpoint at... Do screen scroll. Actually, I think I will put my break right after it cleared the top line, because I think it's doing that much correctly. Maybe. Hopefully. Let's see. Either way, that should be load a scroll value, which is 0.5, clear carry, add with carry. Let's hunt for that, shall we? Actually, I think I should just look for load a 7D, because that's going to be pretty obvious, and that is right here. So we store in PPU data, decrease X, branch, and finally this would be the tail end. So E1, E4. E1, E4. Break on execute. Make sure we're running. Uh-oh. Uh-oh. Oh no. I hid the menu. Shit. How do I reset? Oh my goodness. And just like Alt menu options don't work. Okay. Let's just Google FCUX. Hidden toolbar. To unhide it, press escape. Oh. There we go. That was frightening for a hot second. Reset. Okay. Theoretically, one would think that would have cleared out PPU memory. This just doesn't look right at all. Unless it's writing to the wrong area. Let's look at regular memory. And double check. I mean, our screen address is 0000. Unless, like, the increment just isn't turned on for some reason and it just keeps writing the same thing, but were that the case, then that place in the PPU should be 0, and it doesn't really look like it. Because 2000, which should be the beginning of this screen, is 7E. Which is not correct. Let me just, for fun, look at the name tables. It looks like it's already scrolled for some reason. Like, this interface is not great. I don't get that, but like it's like we've got an extra line here. What is that about? Am I going crazy? Or is there totally like an extra line? I don't know how I would really tell that here. I'm losing it, y'all. I'm losing it. Oh, and I've been streaming for an hour and a half. Do I give up for the moment? Because this is a super duper low energy stream. And it's 11 o'clock. I am super sleepy. I hate to do this, but I got to give myself credit for streaming, 6 days out of the week. So I think I'm going to call defeat for a second. We're getting somewhere. But we're just not quite where we need to be. And I don't quite understand what is up here, because this loop should have written something somewhere, and I see nothing nowhere. Let me do one last check to see if I'm going crazy and 2000 isn't the beginning of that name table. I think that's very optimistic. Yeah, 2000 is the beginning of that name table. So, I mean, maybe clearing out that line is happening, and there's just an extra line that I'm not accounting for. Like, looking at the name table viewer, right here at the top, it looks like there's a line up here. I don't know. Maybe let's keep stepping. See if I can't figure out why the scroll is being funky. And then probably call it for the day, because I am dying. I am feeling so sluggish. So let's just keep on rocking and rolling. So the next thing that would happen here is that we load a 06, and 06 is our scroll offset. So we load our scroll offset, clear our carry, add 8 to it. So that looks right. A is now 08. And we compare it with F0, which it of course is not. If they were equal, we would jump to E1EF, which is our wrap that step, but that's not going to happen. So we're just going to store it back into 06. Then we are going to load 0 into... Oh, well, there's a thing. There is a thing. Yeah. We're not jumping over this yet again. I have overlooked... overlooked that a couple times now. Clear carry, which I can probably guarantee that carry was clear anyway, but clear carry, branch carry clear to print char end. Because otherwise, scroll value would never get reset. There's that. And because I already know that that would break things and it's not going to work, let's rebuild and reset. Maybe I should clear this breakpoint and run and reset and open the thing and see if it at least scrolls now. Huh, it scrolled. All right, that ain't right. And then it just stopped. So it's something. Okay, interesting. Is that because... So I don't know if you could quite see that. Derek Koenigsberg said at some point, the problem has to be something extremely stupid, but good luck finding it. Bug in the documentation. I'm sure it's not a bug in the documentation. It's a bug in my brain. God damn, I'm so freaking close. But I think I gotta call it. Oh no! Coco says, it's 4 a.m. here, finally I get to watch this, and I was just about to talk about giving up and turning in. Okay. Alright. One more push. Always one more. Always one more. What can be going wrong here? So I don't know who all saw that, but basically, actually let me reset it and you can see it again. So it gets the end and it scrolls the first... Oh, well, now it's just not doing anything. Oh. Okay, that's even weirder than I thought. So it gets to the end. Doody, boop. And then it just hangs out for a minute. Then we scroll. You know what? I actually want to check really quick. I feel like there's a few things going on here, but I think it's possible this whole time this part where it wraps and then keeps writing for a while may have potentially been happening the whole time. So let me check that, because maybe I'm not starting checking, or I'm not doing the actual screen scroll in the right spot. So looking again for load A01 store a PPU address. Wait. No. Wait. Yes? No. Yes. Yes. So that is load a address. Load a screen address +1, which is 01. Store to PPU address. Is it here? Load A01, store PPU address. Load a screen address, which is 00. And E0, yes, it is here. So E1CF. E1CF. And run and reset. And let's keep this open. Okay, reset. And let's see if it wraps. No, damn it, it does it the exact right place. The exact right place. Frustrating. Okay, welp. Let's just step over and see where it goes. Ah, okay, so this is the part where we're going to clear out a line somewhere in PPU memory. 32 times. Oh boy. Waiting for that X to hit 0. Come on. Yay, okay. Then we increase the scroll amount by 8. It did not hit F0, so we store it back to the 0 page, clear carry, and branch to E1F7, which is the I am done portion of things. All right, so wait, why am I load A? Oh, because I'm load A 00 and storing that into the X PPU scroll. Yeah, duh. Then I'm loading the scroll value and putting that into the Y PPU scroll, which didn't update this screen at all. So that's fun. Let's just hit run again and see when it hits this do screen scroll portion again. I mean, I don't know what all just happened. Did it do a scroll? I mean, it surely it did, because our thing just disappeared off the top of the screen. So something is happening. I think it might be working. I mean, yeah, I think it actually might be working. It's just not clearing the right line for some reason. Because so far this looks wait. Hold up. I know what's happening. And that's annoying. Okay, so I can't think this all through right now, but the thing that I am forgetting is that to the left line, that first line that we write, isn't on row 0. It's on row 1, because row 0 is actually off the top of the screen for whatever reason. And so I start at row 1, which means that when I clear row 0, I'm actually clearing the row right above it. But that said, one would think when I get to the subsequent line, it would clear that one? It should be getting cleared at some point. Is it just that Lord. There's activity in chat now, so I am I'm going to take my broken brain and I'm going to go check chat. Derek Koenigsberg says, maybe have the here message increment something each time so you can at least follow what's happening. I feel like you have recommended this before, and it's a reasonable thing to do when you're printf debugging, but I guess I could print an arbitrary character. That's an idea. Yeah. Yeah, I think we can do that. But the thing is, I already know that it's doing the printing. Now the part that I need to figure out is why it's not clearing that line. That's really the issue. But yeah, like trying to print here 1, here 2, gonna be a huge pain in the ass because after you get past 9, you just wrap around to 0 again, and less useful than being able to print actual numbers. And then I'd have to implement a whole convert a number to a string thing. Yeah, big pain. Coco says, how do you even have the perseverance? It's because I'm being watched. And also because I genuinely enjoy this. That's why I'm doing this. It's just, I would have, if it was me working on my own, I probably would have stopped a while ago. But I'm trying to push on for the people. But I might call it, because I think it's working. I think I just have to figure out how to clear why that line is not the one getting cleared. Which I think is related to this whole, I've got an extra line that I'm not accounting for deal. Coco says, I got a job on Monday. Hell yeah, dude. Things come and go. We had a guy who lost his job, unfortunately, who was on here. Actually, Wereworm popped in at the beginning, so he may still be watching. Wereworm, we're still looking out for you. And then we got people getting jobs, and that is awesome. Use Vim. I think the main issue here is lack of Vim. Time to switch to Emacs and skull emoji. I'm too dumb for Emacs, and if it... we stan Wereworm. Hell yeah, we stan Wereworm. I'm using Vim key bindings for Visual Studio Code, so I'm halfway there. Yeah, I think basically at this point, I feel awful. So I hate to have an episode where we don't wrap a thing up, especially when it's so freaking close, but I'm too dumb for Emacs too, Evelyn says. Aren't we all? Not all of us can be zoning. Yeah, so I'm gonna call it here, guys. I tried. I really tried. And we're close. We're so close. We're so close. Oh, don't cry. Don't cry. Not in front of the people. So yeah, I think that's it. Coco says bye. And before we go, one last thing from Derek that I enjoy is Vim is cheating. It lets people claim they prefer Vi over Emacs without actually having to experience the pain of using real Vi. You're probably not wrong about that. All right. Thanks for tuning in, everybody. Sorry we couldn't have a more impressive ending, but one more push and we will have this. And character printing will be done. This is the very last thing. The very last thing. But I'm too frazzled for this right now, so see you guys. Love you guys. Bye.